We'll get started.
Good morning, sir.
Yeah. Get started. So today our topic of discussion is going to be polarization, right? So this topic is not dealt in seriously, so I'll teach it on at least the concept first, and then there will be a few problems based on it. Okay. If there is any doubt, let me know. So this polarization has nothing to do with the polarization that we learned in capacitors. Okay. This polarization is called as polarization of light. Okay. So before we get into this topic, we need to know certain facts. So what is light? It is an electromagnetic wave. So light is an electromagnetic wave. And what is the speed of light? Speed of light is given as E divided by V. We know this fact, right? That is electric field divided by the magnitude of the electric field to the ratio of magnitude of electric field to the magnitude of magnetic field is what we call it as the speed of the light. So speed of light is almost 3 into 10 power 8 meter per second. So if this value is this high, tell me out of the electric field and the magnetic field, which one is dominant?
Electric field.
Obviously the electric field, because that is in the numerator, right? So when the electric field is going to dominate, we need to observe how the light is actually going to get transmitted. We know that light will transmit in the form of electromagnetic wave. That is, the electric field and the magnetic field will be perpendicular to each other, and they are mutually perpendicular to the direction of propagation. Right? Now, since we know the fact that the electric field is the dominating one in the case of an electromagnetic wave, for you to have light, basically light is classified into two types. One is called as unpolarized light, and the second is called as polarized light. So what do you mean by unpolarized light? So unpolarized light is the one in which the electric field vector of the light is vibrating in all the directions. Are you able to understand this? So if you have light in which the electric field is vibrating in all the directions, then that is what we call it as the
Unpolarized.
It is called as unpolarized light. Right? Now, if you are able to make this electric field get confined and vibrate only in one particular direction, then that is what we call it as polarized light. So let me show you something.
Light is an electromagnetic wave in which the time-varying electric field vector E sometimes
See, actually, you will not be able to hear, but I'll explain. You're able to see that the electric field in the orange line and magnetic field in the green line are perpendicular to each other, and white line represents the direction of propagation. Right?
Yes, sir.
B are mutually perpendicular to each other.
So this is
and
what
also perpendicular to the
light is
direction
made
of
up
the
of, electric
propagation
and
of
magnetic
light wave.
fields. Now you're
A
able to see
phenomenon in
this.
which the light electric vector
If you represent
Yes,
everything on a circle in the form of with the use of radial vectors, then you can see that the electric field is confined to one direction, magnetic field is confined to one particular direction.
or vibrations are confined to a particular direction in a plane is called polarization. The transverse nature of light can be demonstrated through polarization of light wave using tourmaline crystals.
Now see,
Take a tourmaline crystal A having crystallographic axis AA dash.
when light is coming from the torch, right? There is a torch light, and there is a crystal placed in between. Generally, they call it as tourmaline crystal. That is acting like that is going to be a polarizer. What it is, I'll explain it slowly. So, if you observe, when the torch light is actually coming out, right, you can see in that light that the electric field is randomly aligned in all the directions. Okay, I'm repeating it again. Electric field will not be confined only to one particular direction. Rather, it will get confined in all the directions. It is scattered. Okay, if that kind of a light is present, then that is what is called as unpolarized light. Now, see what will happen to the same light after it comes out of the crystal.
Of a beam of
What happened?
ordinary unpolarized.
The electric field vector got aligned to a particular direction.
The electric field got aligned to a particular direction. That is only along y direction. Right? So, after passing through the crystal, it is coming out. No, the light which is coming out is what is called as polarized light, or they call it as plane polarized light. Are you able to understand? Okay. The best example is the light coming from sun is unpolarized light. Will you be able to see it directly? Will you be able to look at the sun directly? The obvious answer is no. Or sometimes what will happen, you cannot, when it is sunny, right, you cannot even see certain things when the light is falling on certain objects. That is because unpolarized light is falling on it. But you can look at the same object with the help of sunglasses. Did you ever feel it practically? You're able to see those things with sunglasses because when you wear sunglasses, they polarize the light and send it to your eyes so that the intensity decreases. So now I'll come back to the theory part. Listen. When the electric field vector is going to be in all the directions like this, okay, then that kind of a light, this is only electric field vector, okay, then this kind of a light is what we call it as unpolarized light. Like what we can do is, look at this ray, this ray, this ray, all these rays can be resolved into X component and Y component, such that what we will do is, we will take the resolution of all the vectors and write them or draw them only in the form of, we will align them to two directions. What are the directions? X direction and Y direction. Here, if you see, this ray is in XY plane, XY plane, XY plane like this. So I resolved them into components. I took the resultant of all these waves along X direction and I took the arrow mark in the X direction. I resolved all these components in Y direction. I took the arrow mark only in the Y direction. I hope this point is clear. So when the light ray is vibrating like this, when it is vibrating in two directions like this, the resolved one, then this is what we call it as unpolarized light. When you pass it through a device called as a polarizer, the best example is your sunglass. Then what will happen is, depending on what is the axis you're trying to place, one will be pass axis, one will be cutting axis, filter axis. So depending on the axis of the polarizer that you place, when the light rays are coming out, no, one of the directions will get cut off. That's what is shown in this video. See.
AA dash and place
That
it in the
AA
path
dash
of
is there,
beam
no?
of
That AA dash is what is called as the axis of the polarizer. So that is a pass axis. Means from AA dash, if you see, the vibrations are coming out, right? Those vibrations are nothing but, those are the directions in which the filter is allowing it to pass. The other direction, whatever is there, the Z or Y direction, it has got completely filtered.
ordinary unpolarized light from the source S. When unpolarized light from the source S of original incident intensity is passed through the tourmaline crystal A, less intense, rotating the tourmaline crystal.
Now see what will happen
and
if
the
the axis
observer
is
at
tilted.
point O.
Are you able to
On
observe?
rotating the tourmaline crystal
That particular
A
direction
about
is what
the
is
light
allowed.
beam SO as axis, we do not observe any change in the color of the emergent beam. Its vibrations polarized light B dash and place it in the.
Harini, tell me one
Sir,
thing. Are you clear till this point? Yeah.
yes, sir. But I have this doubt. So the final electric field vector is aligned parallel to the axis of the polarizer.
Exactly. It will be parallel to the axis.
Yes,
It
sir.
will be parallel to the axis. Okay.
Taken
Now
at the
see,
tourmaline
they use one polarizer to show you what is a polarized light. Now what will happen if two polarizers are used? See.
crystal B, having crystallographic axis
So A dash is
B
one
dash
polarizer.
and
So
place it
what
in
is
the path
happening
of.
to the unpolarized light? So what is happening to the unpolarized light after it has passed through the first polarizer? It has got polarized. Means one of the directions have got eliminated. So when the light is already polarized, why do we need to pass it through a second polarizer? Okay, the second polarizer is used like a layer only to decrease the intensity. Okay, only to decrease the intensity of the polarized light. Are you able to understand? No? So the first one is called as the polarizer, and the second one is called as the analyzer. Though it is also a Polaroid only, but only thing is it is an analyzer. Imagine like this: you have two aluminum foils in your hand. When you place one aluminum foil itself, whatever you wanted to achieve, you have achieved. You are placing the second aluminum foil on top of the first one just as a filter, an extra layer. That's it. In a similar way, these two are still polarizers only. The first one is used to polarize the light. The second one is used to control the intensity. Okay. So the one which is used to control the intensity is what we call it as the analyzer. If you're clear with those points, I will explain the theory part from here. Are you clear?
Clear. Yeah.
Okay. Yeah. So what is polarization? The phenomenon of restricting of electric fields of light into a single direction is what we call it as polarization. When I talk about ordinary light, it has electric fields in all possible directions in a plane, perpendicular to the direction of propagation. When the ordinary light is passed through a tourmaline, calcite, or quartz crystal, the transmitted light will have electric field vectors in a particular direction parallel to the axis of the crystal. So your doubt got clear? Parallel to the axis. This light is known as the plane polarized light, or simply they call it as polarized light. Okay. These are the other two important points. So if you are able to define a plane which contains the vibrations of the polarized light, then that is called as the plane of vibration. If you take a plane perpendicular to the plane of vibration, it is called as plane of polarization. So polarization can take place. So please note this point. Polarization can take place only in transverse waves. So let me explain what this plane of vibration and plane of polarization mean. See, the final electric field is present in y direction. Okay? If I take a plane and I keep it like this, then this plane in which the vibration of the polarized light is present is what is called as plane of vibration. So the plane which is perpendicular to this, that is the layer which got cut off, that plane is what is called as plane of polarization, because it has got polarization. So plane of vibration is the plane to which the polarized light is passing. Plane of polarization is a plane which is perpendicular to the plane of vibration. Are you clear with this?
So can you repeat the first part?
This is the direction and see. The unpolarized light has come out of the polarizer. It is vibrating only in this direction, y direction. Through this vibration axis, if I take a plane like this, then this is what is called as plane of vibration. Because this is the plane in which the vibration is present. The electric field would have been like this initially. This would have also been there because we resorted to two components. Now,
Yes, sir.
this one has got cut off. So the plane which is perpendicular to the plane of vibration is what is called as plane of polarization. So the plane which is passing through the vibration of the polarized light is called plane of vibration, and the perpendicular one is called as plane of polarization, the one which is called polarized.
Clear, sir. Yeah.
Now what will happen is, see, let's say unpolarized light is here. That is, I use a torch light. This is the polarizer, this is the axis. After passing through the polarizer, the ray is coming out like this. Then what? This is a polarized light, have it in your mind. Then I'm placing another polarizer in between. And the other polarizer will also have axis. So if this polarized light is allowed to pass through the second one, exactly parallel to the first one, what do you think will happen? So by left hand is the first polarizer, right hand is the second polarizer, which is technically called as an analyzer. So torch light, here you have polarized light. So polarized light is passed through the second polarizer. What do you think will happen?
The intensity will decrease.
The intensity might change, but actually what will happen is when both the axes are parallel to each other, the intensity will remain the same. Okay. So if I have to control the intensity, so between these two there is polarized light. I cannot hold all the way. I put it into storage. So pink color one is a polarized light. When I pass the polarized light through the analyzer by tilting the axis, if I keep tilting the axis like this, then yes, I can control the intensity. Are you able to understand that? And that intensity is controlled by using a law called as Malus law. Harini, are you clear? Is there any
Sir,
point you want me to?
I have this doubt. Like your video is slightly lagging. So if the analyzer's axis is parallel to the axis of the polarized light, then what will happen?
Intensity will be the same.
Oh, okay.
Okay. So that's what the law of Malus states. What they state is when you have a beam of completely plane polarized light. So remember this thing, when as soon as the light is passing through the first polarizer itself, the light is completely polarized. So when a beam of completely plane polarized light is incident on an analyzer, the intensity of the transmitted light from analyzer is directly proportional to the square of the cosine of the angle between the plane of transmission of analyzer and polarizer. So the intensity of transmitted light is directly proportional to cos square theta. Please make a note of this point. I'll draw and show. See, if the intensity of the light is I naught, intensity of which light? Intensity of the unpolarized light is I naught. As soon as it passes through the first polarizer, the intensity will decrease to I naught divided by 2. Why is it becoming I naught by 2? Because initially it had two directions of vibration after resolving. After it is passed through the polarizer, one of the directions is completely cut off. So the intensity will become I naught by 2. Am I clear with this? Right. So
Yes,
this is
sir.
called as, this is the intensity of, so what do you have? Unpolarized light pass through a polarized light. Then you will have polarized light. Then the polarized light is passed through an other device called as an analyzer. And the one which is coming out of this is what is called as transmitted light. Okay. So the law of Malus speaks about the intensity of the transmitted light. So if I naught is the intensity of the unpolarized light, then I naught by 2 will be the intensity of the polarized light. When I naught by 2 is passed through the second polarizer, the intensity of the transmitted light is observed to be directly proportional to cos square theta divided by 2, where theta is angle between axis of polarizer and analyzer. Please make a note of this point.
Done, sir.
Done, huh?
Yes, sir.
Now see, I is directly proportional to cos square theta by 2, no? Then I is equal to I naught by 2 times cos square theta by 2, where I naught by 2 is what? It is the intensity of polarized light. Polarized light means the intermediate one. So first is unpolarized, the intermediate one is polarized light, and the third one is called as the transmitted light. So I is equal to I naught by 2 times cos square theta by 2. Done. So this is the concept on which the problems will be asked. So this is one of the laws which has a mathematical equation for it. Shall I proceed to the next one?
Yes, sir.
Okay. So when ordinary light is incident on a polarizer, the intensity of the transmitted light is half of the intensity of the incident light. When the polarizer and analyzer are perpendicular to each other, the intensity of the transmitted light from the analyzer becomes 0. See, I made a small mistake. I wrote it as theta by 2. I'm sorry about it. It is theta. Please make this change. It's theta. Okay. So remember, if the polarizer and analyzer are perpendicular to each other, okay. See, going forward, I will draw the polarizer like this. You need to understand that this is the axis, and this symbol represents polarizer. This is for your understanding. Okay. So when the polarizer and analyzer are perpendicular to each other, the intensity of the transmitted light from the analyzer becomes 0. And this is a situation which is called as crossed polaroids. Sometimes they will use the word the polaroids or crossed. Polaroids is a device. Polaroid or polarizer both mean the same. Crossed means they are perpendicular to each other. Clear?
Yes, sir.
Okay. The next one is called as Brewster's law. So this law states something like this. When you have an unpolarized light which is incident, see, let's say, before I get to the concept, tell me one thing, have you ever observed this? Suppose you have a water body, okay? Then you stand near it, you try to observe the surface of the water body. There will be certain spots where you cannot directly look with your eye. You'll feel so much of glare and you'll have a lot of disturbance. Have you ever experienced it? especially during afternoon.
Yes, sir.
Okay. The reason why that is happening is because, repeating, the reason why that is happening is because the unpolarized light is falling here, and when it is getting reflected, it is not getting completely polarized. Okay, there will be, so whenever there is an unpolarized light falling, whenever light is falling on a surface or a transparent surface, we think that light will only get refracted. No, the light will also get reflected. That is why you are able to see something. Okay, so you are actually looking at an angle where the reflected light is not polarized at all. See, suppose you have an unpolarized light which you can make it incident at an angle of polarization. If suppose you have an unpolarized light which is going to hit the surface at what? At an angle called as the angle of polarization on the interface separating the air and the medium, then the reflected light becomes fully polarized. Means the light which is getting reflected will get completely polarized. That is what they meant. Then that so-called angle of polarization is what is called as Brewster's angle. So you're able to understand, unpolarized light will fall with different angles of incidence. But there will be one particular angle of incidence where if you observe the reflected light, you can say that it is completely polarized. Such an angle of incidence of an unpolarized light on the interface is what we call it as the angle of polarization. Puridama?
Sir, this is a natural phenomenon.
It is a natural phenomenon. Yes.
Yes.
Okay. And one more thing, when this is getting completely polarized, no, the reflected light and the refracted light will be perpendicular to each other. So make a note of this point also. The reflected light and the refracted light are perpendicular to each other. When this kind of a scenario is going to occur, now let's try to calculate what that angle of polarization is equal to. So if I take this as the angle of polarization, this will also be IP only because laws of reflection states angle of incidence is equal to angle of reflection. So if I take this as R and the medium's refractive index as mu, then sin IP is equal to mu times sin R. Correct? So this is 90 degrees. IP plus R plus 90 degrees is equal to 180 because it completely forms a linear curve. Then what the value of R? R is 90 minus IP. Take this and substitute it here. Then sin IP will be equal to mu into sin of 90 minus IP. So how much will you get, guys? Sin IP is equal to mu times cos IP, which implies tan IP is equal to mu. So IP will be equal to tan inverse of mu. So this is how you calculate the angle of polarization or the Brewster's angle. Clear?
Yes.
Okay. So that is all about polarization. Now we will do some problems. 1 minute. Let's try this one. So there is a system of 3 polarizers P1, P2, and P3 set up in such a way that the path of P3 is crossed with respect to P1. So if I take this as P1, then the cross axis of P3 is perpendicular to P1. Are you able to understand this? Cross means perpendicular. The path
sir.
axis of P2 is inclined at 60 degrees to the path axis of P3. The path axis of P2 is inclined at 60 degrees with whom? With P3. Then how much will this be?
30.
Obviously 30 degrees, right? When the beam of unpolarized light of intensity I0 is incident on P1, the intensity of the transmitted light by the 3 polarizers is I. Transmitted light, na final hour light. The ratio of I0 by I is how much? So here if it is I0, how much will be the intensity of light this side?
I0 by 2 cos square.
Yes. No, it is
I0
only
by
I0 by 2. Yeah, first one the I0 by 2. After analyzer only Malus law comes. So this is the first analyzer, this is the second analyzer. So if I call the intensity of transmitted light I dash here, I dash will be equal to I0 by 2 times cos square of what is the value of theta I need to take? Theta is the angle between the path axis of the first polarizer and the second polarizer. How much is the path axis?
30 degree.
Very good. So it is I0 by 2 times cos square 30 is 3 by 4. That is 3 I0 by 8. So the intensity of light coming out here is 3 times I0 by 8. Now the intensity of the light that is coming out from here will be equal to intensity of the previously polarized light, that is 3 I0 divided by 8 into cos square of how much is the angle between the path axis of P2 and P3.
60.
Did you understand why I took 3 I0 by 8?
Yes, sir.
So that intensity, whatever you are multiplying with cos square theta, should be the intensity of the one which is on the left of the polarizer. So 3 I0 divided by 8 into cos square 60 is 1 by 4. So 3 I0 divided by 32. So how much ever is the answer? This is I. So here in the equation, I0 divided by I will be equal to 32 divided by 3. 32 by 3 is how much? There is no option that is matching. 32 by 3, it's 10 point something.
Yes, sir.
So that's it. That is how you solve problem based on polarization. If you have copied it, I'll move on to the next problem.
Yes, sir.
Do you have the book which I gave you in your hand now?
Yes, 1 minute.
Can you take screenshots and send me some problem based on polarization?
So there are no example problems after this.
Yeah, you can send me those screenshots.
Sorry, sir.
You can send me screenshots of those questions. Did you send now?
Yes, sir. I found one problem.
There's only one problem.
Yes, sir. Other kuda it's there in practice exercise only.
Because there is nothing much to ask in the concept. See, you did this problem, no? This, if I have to be frank, this is the toughest problem in based on polarization. There is nothing tough. Brewster's angle, obviously, it is simple, right? So, if the CS paper, if you try to take and solve, so what I suggest is you consider a light beam incident from air to glass slab at Brewster's angle as shown in the figure on the next page. The Polaroid is placed in the path of the emergent ray at point P and is rotated about an axis passing through a center and perpendicular to the plane of the Polaroid. For particular orientation, there should be darkness as observed the Polaroid. The intensity of the light as seen through the Polaroid shall be independent of rotation. Are the option?
Yes, sir.
One minute. So consider a light beam incident from air to glass slab. Air to glass slab at Brewster's angle. So angle of incidence is IP. Here also the angle of incidence, angle of reflection will be IP. A Polaroid is placed in the path of the emergent ray at point P. So there is a Polaroid placed at point P and is rotated about an axis passing through the center and perpendicular to the plane of the Polaroid. Okay. For a particular orientation, there should be darkness as observed through the Polaroid. So tell me one thing. This is unpolarized light. So this is going to be completely polarized light. This is partially polarized. This is also partially polarized. So what do you think will happen? What do you think will happen?
Option A, sir.
How are you saying?
Because it's like partially polarized. So when we rotate the axis of the polarized.
But you need another, like, I'm thinking that this thing. Suppose its intensity is I dash natural. Then I can write dash I dash cos square theta, but what is theta? But what is theta, ma? Theta is the angle between. Theta is the angle between
the axis of the Polaroid and
axis of both the polarizers. Here you have only one polarizer. So complete darkness is not possible. Complete darkness only when they are crossed polaroids. The axis is first polaroid. This is not a polarizer. Glass slab is not a polarizer. Right? Second, the intensity of light seen through the polarizer is independent of rotation. No, that is also not accepted. See, the intensity of light as seen through the Polaroid shall go through minimum but not zero for two orientations of the Polaroid. Yes, it is possible. The two orientations will be in such a way that one will be acute angle, one will be obtuse angle. The intensity of light seen through the Polaroid shall go through a minimum for four orientations of the Polaroid. So option is C.
Sir, இங்க வந்து அந்த two orientationன்றது it's x axis and y axis தானே sir?
No, not either. See, sometimes let's say cos square theta when you problem solve when you get cos square theta is equal to 1 by 2 வருது அப்ப cos theta என்ன வரும்?
1 by root 2.
That is where we make it is plus or minus 1 by root 2. So cos theta is 1 by root 2 is 45 degrees minus 1 by root 2 is 135 degrees. That is what I meant by two angles.
Okay, sir.
Okay. So when you have two different orientations, yes, you can actually polarizers axis can control the intensity. That's for sure. But it cannot go to zero because you don't have another polarizer which can actually make it crossed. Correct? Another option C is the only one that is satisfied.
Yes, sir.
Okay. So, இவ்வளவுதான் problem. What I suggest is take your NCERT, solve the problems. Okay. அதுவே நல்லதா இருக்கும். Take NCERT problems and solve them. Do you have SL Aurora?
No, sir.
You don't have it? Okay, I'll do one thing. I'll search for it and I'll send you screenshots. Those problems are also good. You can try them. இவ்வளவுதான் polarization.
Yes.
Okay. So try panni. If there is any doubt, let me know. So the other day you sent me a problem. No? I have to check it. What is it? What was the issue, Adra?
Which problem, sir?